Good afternoon, everyone, or good morning, depending where you are in the world. Thanks for joining us today. My name is Paula Hopp. I work at Datamine's office in South Africa, and I'll be taking you through the second part of our Studio P webinar series today. Last week, Bruno showed us how to use our dynamic PID design functionality to quickly create some pretty nice PID designs, and from there, I want to take you through the data preparation steps and show you how we can create a basic schedule on OP. My main goal today is to get us to a simple loading schedule at the end of the session. And next week, we can explore a bit more the scheduling capabilities and look into more options. This session will take around 35 to 40 minutes, the same as last week, and questions can still be sent to sales@dataminesoftware.com. And we'll address each of those individually. If there's any questions that might be relevant for everyone, I can address those on next week's webinar. After we finish with the webinar, you're going to receive an email with the recording from today's webinar, and you can share that with people that couldn't make it or watch it later. And also on that email, there's going to be a small survey about our webinar. So I would really appreciate if you guys took the time to go through it so we can improve for our webinars going forward. So that's it. Let's get started. Okay, once again, we are in OP. I'm hoping a lot of you are using it or have seen it, or at least on last weekend's webinar. So we are already on the ribbon setup, right? Last week, Bruno went through the setup ribbon and the PID design, the design ribbon on the PID modeling part. Today, I'm going to go through the setup ribbon again, the reserves ribbon, where we're going to prepare our data for scheduling, and the schedule ribbon. I'm going to go through this ribbon quickly, and next week we'll come in more detail to see all of the options here. Okay, so just for us to get used to the data we're going to use during the webinar. So from last week's webinar, I think the second example from Bruno was the PID design. So we're trying to use the same data as much as possible so we can create some coherence between the sessions. So from this full PID design, we created a couple pushbacks. So pushback 1 here and pushback 2. You can see here it's more on the right side. It also doesn't go all the way to the bottom. And then the final PID shell will be our pushback 3. So we can see here there are pushback 2, the blue wireframe, is going inside pushback 1, right? So we did this on purpose so we could see how the software handles this type of data. It won't be a problem. You're going to see how the software is now working with the order of the pushbacks. Okay, so let's start on the setup again. So one thing that I wanted to point out is Studio OP now is creating, every time we start a project, we create this OP database on the background. So it's every setup that we do, every file that we create on the reserves, and all of that is getting saved on this OP database. So this is really good because if you close the software and open it again, it's there, but also the software uses the right data, it saves the data for you. We don't have to be worried too much about what we are creating and where is it going. It's being managed on the background, the settings and the files that we're creating. So let's start with the setup, the same as we did last week. Every time we click on a task, it opens a task control bar and a task window that we're going to use today. So the first, we're just going to give a name to the PID. Let's continue from last week. PID A. We're going to select a topo and apply this topo to my PID A and save. The next step is to define our block model. So our planning model, so we can select a planning model. I did some modifications on this model for this webinar so we can see some of the functionalities. As soon as we pick the planning model, it automatically picks all the fields from the block model, and you can here assign what those fields represent. So in this case, rock type is going to be my category. Density automatically picks as density, gold as grade. If you remember last week, we picked geotech as slope regions. So here's where you can assign these different categories for your fields. Today we're not doing pit design. I'm not even worried about the slope angles. So I'm going to assign the planning model to my pit A, save, and move to my validation. What is the validation doing? The validate is going to run through the whole model, and this is something we probably all of us used to do, and quickly create a stats. So a summary. What are the minimum and maximum of the rock type, density, gold? This is really helpful for us to see if there's any issues with our block model. If the density is from 25 to 35, you know automatically you need to go and double check that, right? You can see here that even it's telling me the gold is -1. So I need to check what's going on there. So one thing that I wanted to show you that we skipped last week is this option here. So what is this? This part of the validation brings me how many absent, how many negative values are in each of my fields. This is quite good because one thing that happens a lot, for example, is grade. So a lot of times when we get resource models from geologists, sometimes the gold is absent on the waste zones, right? And for planning purposes, it would be better if it was 0. So here it's telling me I found a lot of absence and 14 negatives on gold. So now instead of you having to go back and create a whole process to fix this problem, you can easily put here, okay, I want all the absent values to turn into 0 and all negative values to turn to 0. And you just click fix, and on the background is going to fix the block model for you and save it on the database that I was talking about. So you can see now no more absence, no more negatives. Even on the summary, now the gold, the minimum is 0, which is more in line with what we wanted. So we save. Next step is to set up the pushbacks. So as we discussed, we have 3 pushbacks. You can change the names here. I'm just going to keep as is. And the last step, if you forget to save, the software prompts you to save. So yes, I want to save. And so now we need to define our benches. Last week, Bruno showed an example through the planning model. And today, let me just show you how we can use a string file. So for example, you can just pick the final pit design and apply. It reads the pit design, it selects the toes and the heights for each of the benches automatically, so you don't have to do this manually. So we can save, and we're done with our basic setup. Let's move now to the reserves. So this reserves, this is new now, right? What is the main goal here? On the reserves, what we want to accomplish is at the end of the reserves, we want to create a data set for scheduling. So we want to have at the end of the day mining blocks, blast outlines, so the solids we want to schedule, the information about tonnage, grade, rock types on each of those mining blocks, even sequence and so on. So this is my objective here. So I want at the end of these reserves to have all my data prepared to start scheduling. So the first step is to add my DTM. So I'm just going to pick, so I already have my block model, I already have my topo and my bench heights. So I'm just going to select here my pushback strings, right? Pushback 1, pushback 2, and my final pit. So let's take a look. So these are my designs. Okay, pushback 1, pushback 2, pushback 3. If you have the DTMs, you can bring them automatically here. In this case, I'm just going to create them. So quickly you can see here, we created those wireframes that I showed you in the beginning, right? Once again, you can see pushback 2 going inside pushback 1. So let's save. Next step is to create the pushback solids, the phase solids. So what are we trying to do here? Here I'm trying to create a big solid that represents everything that needs to be mined on that pushback. So for example, on pushback 1, I'm looking at pushback 1 and at the topo. So what I want is a solid that represents everything that is underneath the topo and inside pushback 1, everything that is going to be mined on pushback 1. So let's just create that first one only, just so we can understand. So you see now it creates this pushback 1 solid. So this is the volume that represents everything that needs to be mined on pushback 1. So we're going to do the same for pushback 2 and 3 now. So let's just create all of them and see what happens. So this is where the order of the pushbacks is important. The software understands how the pushback 1 interacts with pushback 2 and interacts with pushback 3. So for example, on pushback 2, what do I want? I want everything that is inside pushback 2, underneath the topo, but also that is constrained by pushback 1, right? Everything that is inside pushback 1 has already been mined. So let's see what the solid created for pushback 2. So you can see, because of the order, the software already understands that everything inside pushback 1 is gone. So it creates the solid for only the part that is inside pushback 2, but it's outside of pushback 1. And let's just see all the solids now. So you can see here, if I mine pushback 1, then the solid for pushback 2, and what's left is pushback 3. So those are the big solids. One thing that I like to point out here also is sometimes when you're doing our pushback designs, we don't do the wall perfect between the two pushbacks, and there's this leftover skin here, this little solid there that really represents just that my walls are not perfectly aligned. So you can go back and redo your design, or we created like a tool to help us clean a bit the wireframe when this happens. So we can use this remove solids with volume below or thickness below. So I'm just going to rerun, and you can see the process of creating the solids is quite quick. So everything that is below the volume of 1000 or the thickness of 2 disappears. So you can see that those small little wireframes there are now gone. Okay, so now I'm happy, my wireframes are clean, and I can move to the bench solids. Let's save and move to the bench solids. So the bench solids now, we're just going to take the face solids and cut them with according to the bench heights we set up. So let's just create all. So created those bench solids there, right? Here on the bench solids, you can see there's even this small little solid there. So I can use the same tool to deplete. So this is just something that was left on the topo. Maybe the topo moved a bit. So I'm just going to recreate, deleting anything that thickness is smaller than 1. So already gone. So it creates, you can see by the color that already divided all of this into bench solids. And you can see here it creates the outlines also, bench outlines. One thing I wanted to point out here is from now on we are using the solids for evaluations and for scheduling. Everything we're doing, we're using solids. So of course we have the outlines here, the bench outlines, but this is just a representation. When we do the evaluation, we're using the solids itself, so our evaluations are precise. So from the bench solids, our next step is to create our mining blocks. So there are 2 ways we can create our mining blocks. So the first one is a automatic way. So I'm going to tell the software, in this case, through my entire life of mine, 20 years, I want everything to be split into weeks, right? So I just want to divide my bench outlines into week size blocks. They're not going to be precise weeks. They're an approximation of a week, right? How does the software know how much is a week? So we can come here and we can add. We can say, look, 1 year of my mine, I'm mining 3.5 million tons. Okay, so let me just put this to run, create blocks. So what is this doing? So I told the software 1 year of my mine, I'm mining 3.5 million tons. It's going to back calculate what is the tonnage for a week, and it's going to try to divide now my bench into approximately a week size block. Okay, it's complete. we can see here that it automatically divided all my benches into mining block solids. It gives them a name, right? And let me just show you, even creates this sequence for me automatically. Bench by bench, right? Pushback by pushback. Okay, so you can see it's actually creating solids and not just the outlines. It's creating the mining block solids. Okay, this is good, but maybe you tell me, Paula, this is good for long term, but I wanna, on the first pushback, I wanna create my own blocks. I wanna do them manually. It's not a problem. You can come here on manual and we can combine both options. So as soon as I click on manual and I click on a bench, you can see it already brought me the blocks that were done on the auto. So I can either keep this or I can delete those. Okay, so let's just talk about this interface a little bit. Here you can select your pit and which pushback do you want to create your manual blocks. So for pushback 1, then you can here click on each of the benches. It automatically moves to the correct bench. I don't know if you guys remember from last week, but you can use this toolbar here to move up and down also. Keep using benches, right? We have here cutters and blocks. Blocks are the solids. This means that the solids are already created. In this case, I'm just going to clear all. You can see the name of the blocks are gone. And the cutters are these dotted lines that are going to be used to create my blocks, to slice my bench solid into mining blocks. So I'm just going to clear those cutters also. So I only have the bench outline. So what are a couple of options that we have for creating these mining blocks? I can just hand draw something and generate. Or I don't like this. I want to create another string here in the middle. No problem. Generate. If you want to move a point on the string, you can. And you generate, it automatically updates. Right? So all of the design tools are available here. Another option is you can create a trim shot by using the offset and then hand draw something here in the middle and create my blocks. Quick, it's giving the names. You can also bring a grid. I know a lot of people like to use grids, so you can have a grid done beforehand. You import the grid. You can even replace and apply this grid to every single bench and generate your blocks. One thing that I like here is that a lot of the times we create these little small blocks using grids. It's really easy to see when it's creating the blocks because of the naming. So it's easy for you to come here, for example, and delete this one line and regenerate, and your blocks lose those small little blocks that were there. Another option that we can do, let me just clear here. Let me use this one. We can look at our block model. So maybe you want to create blocks around your ore. So you just turn on your block model. This legend is showing everything that is not gray is ore. So I'm just going to design something around my ore here. And then just divide my blocks, my waste blocks, and generate. So you can use your block model as a guide on the background. And the last thing that I've seen a couple of clients use, so I wanted to show you here. You can, if you create your mining block somewhere else, you can, just a second, quickly import them and use them as your cutter. So I'm just going to import the blocks that I have. So I already did these mining blocks in another software, in another project. Someone else did the mining blocks and gave it to me. So you can see here, I can use the mining blocks straight for all of my benches as cutters and just generate all. So it creates all my blocks for all of the benches on this pushback. So just for this exercise, I'm gonna leave like this, and now I'm gonna move to evaluate. So I can quickly evaluate my pit design. I can select my legend here. I'm choosing a gold legend. So this is what I want to have on my scheduling. Evaluate blocks. This is really good, is evaluating against the solids. So that means that even if your block model is not cutted with the topo, not updated, it will give you the right results, the right tonnage. This is very easy, very quick. And even if the bench heights are different, you're going to have the right results all at once. It gives you a small summary here, and we can save and move ahead to my dependencies. So the last two things we need to do is to create my spatial dependencies and my sequence. So my spatial dependencies, those are my undermining dependencies. So these are between benches dependencies to avoid undermining. So there's a couple of options here for you to control between the phases and also for you to control between the benches. So let me just create so we can take a look. So we can see now, it's quick. Let's take this out. So we can see here, it's creating this dependencies between two benches, right? To prevent undermining. I don't want to mine any blocks that are still have any other blocks on top of it. So this is the spatial dependency. And then the sequence, what is the difference? The sequence is now on a bench. So I want to create a sequence on a bench. The sequence is an order. It's not something that you have to do. You can use the sequence on your schedule. You can follow that sequence, but it's not mandatory. It's just an order to guide you, to help you. So let's create one of the examples here. Let's take a look. Let me just clip. Okay, so on this example, so you created a sequence on y-axis. So the machine would start here, move between the blocks following this order, right? You can see there's different sequences through all of the benches. So this can already help you. There's more options here. So you can also use exit points. So if you have your exit points on the pushback, we can do closest to furthest from the ramp point, the exit point, or we can use the optimized model sequence. We'll talk about this next week, but this is how I can connect my production schedule from NPVS. So any sequence that I have on my block model, I can now flag it on my mining blocks for my scheduling, right? So I can connect my scheduling that was done on NPVS, my life of mine, into my long-term, medium-term, short-term. So we can follow the same production schedule. Of course, we're going to adjust, but we can follow the same sequence. We can use as a guide. So this is quite interesting. So from here, the last step is to create a data set. What is that? So we're just going to come here, create a data set for scheduling, give a name, Jan, for January. So what this is doing, this is going on the background on that OP database and picking the files that are required for scheduling. So it's just helping us select all the files that I want to start my scheduling. So now we're ready to move on to schedule, right? So this, I could go from now, click on schedule, start scheduling. One thing I want to point out here, which I really like about these reserves. Let's say I'm January, I did my reserves, I did my scheduling, I'm finished, everything is good. Next month, someone gives me a new topo. So you can come here, add the February topo, apply the February topo to my pit, save, come back to my reserves, and if you just update the solids, reevaluate, and create your sequence again, you can create a new data set for February because of the new topo. So instead of spending a lot of our time updating outlines, reevaluating, updating all of our constraints because of a new topo, we can quickly do that through the reserves process and be ready to schedule. The same thing for a grade control model. if you receive new information on the block model, you don't have to start from scratch. You just update your model here, come to the reserves, reevaluate, create a new data set called Grade Control Model January 2017. So it's really easy for us to update our setup now. It doesn't take those long hours to move outlines and reevaluate. So this is really good when you're on the mine and you need to do things quick. So let's move to the schedule now. So I finished my data set. How do I connect this to the schedule? Easy. We can come here on the data settings and you see scheduling data set. You can quickly pick a data set from here. You can see it's the two data sets that are here. So whatever data set you have saved on your reserves will be available here, and you can pick them to use on a schedule. Just for the sake of time, I created a data set earlier today, and it's the same pit. So I'm just going to use those ones, created a new schedule file, right? So just for us to recap quick, in the beginning we had a pit design, a topo, and a block model. We created all the pushback solids, all the bench solids, everything evaluated, created our mining blocks, created our sequence and our undermining dependencies, right? And created a data set. Now we're moving to the scheduling. So we bring that data set to the scheduling part and we can start scheduling. One thing I want to point out, because today we only have another 10 minutes or so, I'm going to do a quick loading schedule. So there's a lot of options on the scheduling that you're going to see. I might not talk about them today, but we're going to talk about them next week. So today I'm just going to do the basic setup, just so you can see that you can quickly come from a pit design to a quick loading schedule. So let me just turn off the data we were using before and turn on the data that came from my data set, right? So what are the things that I need for a quick schedule? The data settings. Now I create a calendar. So I created a quick calendar here for first 3 months and then monthly, just so we could have some different time frames. You can do yearly, you can do weekly, you can do daily. After that, you have to create some destinations. Here I created 3 destinations, run pad, low-grade stockpile, and a dump. What is important for today is for us to select the categories that can go to this run pad. So I'm saying here, high grade and medium grade can go to the run pad. Low grade can go to the low grade stock, and very low grade and waste can go to the dump. Okay, so this is the different categories can go to the different destinations. The last thing that I did set up for us to do our quick schedule today are 2 loaders. So you can quickly here put a capacity on your loader 1, some availability. Then we can look at loader 2, different capacity, availability. What we could also do is add an adjustment factor. Let's say if the loader is faster on rock type 1 than rock type 2. So I can put an adjustment factor so the capacity of the machine is different depending where the machine is, right? So created the loaders and I'm ready to schedule. So this is the quickest setup. Calendar, couple destinations, 1 loader or 2 loaders, up to you. So you can see here I have my strings on and my blocks on. We don't need this, so let me just get a bit more space. So let's just go to the first period and I'm going to schedule a couple blocks. So we're going to select the wireframes themselves. So it's easy to select, very interactive. Select your wireframes. Then at this time, there's more options here. We're just going to do the loading manual. I'm going to select loader number 1. You can see here it picks the categories and the destinations they are going to. Okay, so reloading. So we can keep this open here. I can select some more blocks on this side, for example. And I can schedule with my loader number 2. You can see those blocks on that area, they're only waste blocks. So I'm just scheduling them. Studio OP is already giving me a warning. So this loader is going to be exceeded on this period. So that means I don't have enough hours to mine all of this that I selected. But what I'm doing at this moment, I'm just going to create a sequence, a mining sequence. I'm going to schedule everything on the first period. And then after that, I'm just going to divide and move through the periods. So let's just, it's telling me the same thing about my trucks. I'm mining too much. I don't have enough trucks. But that's okay. I'm just creating a sequence, a basic sequence on this, right? On this first period. So you can see that I'm only using really the wireframes, the solids themselves, right? The reason why we have the strings here is because you can see this is very interactive. So every time I mine, the wireframes disappear. But let's say I made a mistake and I didn't want to mine this block here or this block. So the wireframes disappeared. So I can bring my outlines, select them, and quickly undo the mining on the blocks that are selected. And you can see it's very interactive. The wireframes are back. I can mine them again. So on that case, I just wanted to mine this and this with a different loader, loader number 1. So it's easy to undo and remine everything. Another thing I wanted to show you is how interactive and how live the reporting and all of those things are connected. So you can see here, as I'm scheduling, the steps here underneath, they already tell me how much I'm sending to the dump, to the stockpile, to the run pad, how much of my machine I'm using, how much is going to the stockpile, how much is going to the dumps. So every time I schedule anything, it automatically updates all of this. So now it's a bit more, 4 million. Let's schedule another one just so we can see. Oops, sorry, there's a block on top. So you see, automatically updates how much is being scheduled, the stockpile, the dumps. This reserves is for me to know what is in each block. I can quickly select any blocks and it tells me how much high grade, how much low grade, how much medium grade. Even if I select multiple blocks, it tells me how much of each of those grades I have on this 3 blocks that are selected. So you can see how everything is really interactive, really on the spot live, which I really like. So as I was saying, I created a schedule, but I put everything on period 1. So now I can come to this activity schedule here. So you can see here, for example, on loader 2, this is a summary of everything that I'm doing on my schedule. You can see there's a lot of information. Start date, finish date, how much tonnage, what is the destination, which truck I used, which cycle time I'm using, truck hours. So all the information about the schedule is here. And also you can see there's some red times here because this is over allocated. So let's say I'm happy with the sequence that I created. I can quickly now here just spill over. This is going to say how much what this is doing is how much my machine. Okay, so I'm just going to do the same for loader 1 and I'll explain in more detail. So loader 1, you can see there's a lot more. So let me just spill over. So what this is doing is how much my machine can mine on period 1. Okay, it's going to mine those blocks. As soon as it doesn't have capacity anymore, it pushes the blocks to the next period. Same for period 2. As soon as it doesn't have any more capacity, pushes for the next period, and so on. So this is an easy way for you to create a sequence and then just spill over through the different periods quickly, right? So this is basically on the scheduling what I wanted to show it to you. So let's save. Let's say I did the schedule and this is one of the options. I can save my schedule here. What is good here also is that I can create multiple scenarios. So I already create 2 schedules here this morning. So you can see now I have 3 schedules connected to the same data set. So I can see what different scenarios I can play around with. So let's just select the schedule that I did this morning so we can look at some reportings. So let's move to period 1. So good, Paula. I created my reserves. I did a quick schedule of loading based on my machines. But how do I report this? How can I quickly show this to anyone, the progress that I did, right? So one thing that is really easy, I can color by animate. Animate is a field that we use to color by the period that is being mined. And I can quickly come here and do an animation. So it's going to ask me, do you want to use the full colors? No, I want to use these ones here. So you can see it's going to mine period by period, right? So it's mining period by period on a quick animation for us. So this is very easy. You can stop. They're back. You can export to Excel, right? So this is very comprehensive. You can see all the information that is here. Truck cycle times, you name it, the information is here. Easy to create a pivot table. Sorry. And we can have, for example, which machine is working on which phase and mining how much tons. Let me just find here. So this is quick reporting that you can do on Excel, and there's so much information on this Excel export that you can do a lot. So you can save your Excel, you can use templates to always have the same reports going on. You can also export to EPS. I'm going to show more detail on this next week. And the last thing that you can do, which we always do also, is create plots, right? So we need to show. So it's very easy. Let me go in a plain view here. If you go to view, there's a quick plot view button. So it brings straight to a plot on the plain view. You can quickly turn on your outlines. Let's color them by the same animate, which is when it's being mined. No symbols. Okay, so you can see the color. Let's put some clipping, move up or down. So we can zoom in on the area, we can create labels, we can use templates, we can really import some title boxes. So after you create your template, it's really easy for you to use the same template over and over and create the plots for which block you're mining on which period. So this is quite easy to use the plot window, and the plot window is connected to the 3D window. So if you change your schedule here, it will automatically update the colors on this side. Right, so yes. Okay, so I think overall this is what I wanted to show you, how to, from a PIT design, pushback designs, block model and topo, how we can quickly, so in 40 minutes we could quickly prepare all of our data, create a couple loaders, and with a bit more time we could easily create a 6-month schedule. So this is it for today. I hope you guys enjoyed, and I hope you guys join us next week so we can see more detail on the scheduling. I think it's going to be really interesting. Thank you very much. Please do go over our survey so we can improve for next week and for the next webinars also. And I hope to see you next week. Thank you.